Welcome to our short circuit video on series and parallel circuits and being able to identify which is which. And I'm going to run through a couple of different methods for identifying circuits that are series connected, parts of a circuit that are connected in series, circuits that are connected in parallel, and how to tell which is which in a combination circuit. So the first thing to recognize is we're going to be looking at some diagrams, and anywhere we've got a black wire like this, that represents a wire of some kind, as I'm showing you on screen now. Wherever we've got a little box like this, this is representing a resistor. And you might have seen other symbols for resistors, ones that look like little jagged lines like that as well. And then we've got the symbol for a battery, a short and a long terminal, plus minus. So that's our energy for the DC circuit, that's our battery. And there are two rules that fundamentally we're going to be applying here. Rule 1 is that branches that only connect two components link those components in series. Okay, so I'll say that again. Branches that only connect two components link those components in series. And rule 2, branches that connect more than two components link those components in parallel. So with those two basic rules, we're going to go through a series, a parallel, and a combination example to see how they apply. So what I would suggest is when we start with the circuit, in this case we've got a series circuit. To help identify and recognize how it's connected, I'm going to go ahead and highlight the different branches or wires, each a different color, so it's clear which one I'm talking about. Now this might seem a bit excessive, but initially it's good to do. Yet after a while, once it becomes clearer which is which, you don't need to keep doing it every time. It's more of a learning exercise. And we've got our voltage supply here. Right, so we have the yellow branch, pink branch, orange branch, and green branch. Now let's think about our rule to start with. Our rule says that branches that only connect two components link those components in series. Well, we've got the orange branch, and it's connecting R3 with the supply voltage only. So it's connecting two components. So according to our first rule 1, that tells us that the supply voltage and R3 are connected in series here. The pink branch connects R2 and R3 only, so that tells us that R2 and R3 are connected in series. The yellow branch, R1 and R2 only, connecting them in series. And lastly, the green branch connects R1 back to the battery only, therefore they're in series. So using this rule, we can easily establish that all the components in this circuit are connected in series. And after a while it becomes clearer, you can tell just by looking at it, because it's a bit like a necklace with different beads on it. All the beads are connected on a single chain. So even if I was to break the battery in half and string it up, you can imagine it being like a group of pearls on a necklace, all connected one after the other. One thing I want to emphasize is, whilst it looks nice to draw out in a fancy shape like this with straight lines and corners, it doesn't matter in the slightest. And we can apply the same logic even to this circuit down here. So let's do that. So again, following the same logic, we've got the green branch here going from our battery component to R1, only connecting two components, so it's in series with each other. The orange branch connects R1 to R2 only, so it's in series. R2 and R3 are connected via the yellow branch only, so in series. And R3 back to the battery with the purple branch only, therefore in series. Now it may look strange in this orientation, but again, it doesn't matter if the resistors are horizontal, vertical, at an angle, it really makes no difference. And likewise, the circuit with a right angle here doesn't change it in any way. The orientation does not matter. We just have to follow where the branch is connecting. And you can see lots of examples in circuit boards where it has right angles, and circuits where the wires curve, and that makes no difference to whether it's in series or parallel. Let's look at the parallel rule now. So what we said was that rule 2, branches that connect more than two components, link those components in parallel. So let's highlight our branches. Here we've got the battery going to 3 resistors, so let's highlight these wires. like this. So remember, we effectively think of this as one single continuous bit of metal or wire that connects from the battery positive here onto these 3 resistors. So we colour that one colour. And then on the other side, if we follow the wire around, anywhere it connects onto, we highlight in orange here. So we've got our 3 resistors here, and we've got our section in green, and we've got our section in orange here. And the rule we said was that if there's a branch that connects more than 2 components together, then that section is going to be in parallel. So we can see here that the battery, our supply voltage, connects onto 1, 2 and 3 components. So that's 4 components connected, so that's a parallel section. Likewise, the orange branch here we can see connects 1, 2, 3 resistors, and the supply voltage, that's 4 components, so it's in parallel. So these 4 components are all connected in parallel with each other. The battery is connected in parallel to R1, R2 and R3. However, there's another way we can identify that these 3 resistors are in parallel with each other, and that's using something called node analysis. So let's run through how that works. So when it comes to node analysis, the first thing we want to do is, when we look at our circuit, identify any place there's a junction where effectively a wire breaks into different paths, or there's more than one path available. Okay, and if we start from the battery and work rightwards, we can see here the circuit splits into 4 directions basically: 1, 2, 3 and 4. So we're going to label this node 1 or junction 1. And then we keep on looking around the circuit, and we can see that the next junction or node is right here, because we've got 1, 2, 3 and 4. So that becomes node 2. So looking around the rest of the circuit, there are no other junctions or nodes where multiple branches connect in. So we've identified all the nodes. Now, how can we tell what's in parallel? Well, if we look at the branch R1 going from node 1 to node 2, and R2 going from 1 to 2, and R3 going from 1 to 2, then we can come up with a rule that says when a branch shares the same start and finish node, then these branches are in parallel with each other. So let's look at our circuit here. Branch R1, which goes up and around, starts at node 1 and finishes at node 2. Branch for R2 here starts at node 1, finishes at node 2, and branch on R3 here starts at node 1 and finishes at node 2. So these 3 branches are in parallel with each other, which means we can apply our rules for parallel, for resistance, voltage and current, to these 3 resistors, in particular these 3 branches. But there's a 4th branch here, and if we say that the branch going through the battery from 1 to 2 all the way around the circuit is our 4th branch, then we can see that it is also in parallel with the branches for R1, R2 and R3. So this is another way of identifying specifically which components are wired in parallel with each other. So finally, let's apply it to our more fluid example at the bottom here. So I'm going to highlight all the branches going from components to component. So here we can see that for the green branch we're connecting multiple components together, more than 2, and then for the orange it's the same. So we've got a parallel circuit, and we can specifically see that R1, R2 and R3 branches all share N1 and N2 as their start and end nodes, and so does the battery. The battery goes from N1 round to N2 as well. So that tells us that the battery is in parallel with R1, R2 and R3. Right, so what happens when we have a combination circuit? Well, let's apply our rules here by highlighting or identifying our nodes and highlighting our branches. This branch, the purple branch, connects only the battery to the resistor, so that tells us that these two components are in series with each other, or from the battery to the resistor. However, our resistor R1 connects to both R2 and R3, and on the orange branch our battery connects, and our orange branch connects the battery to R2 and R3. So in this case, R1 is in parallel with R2 and R3 because it connects multiple components, more than two. The orange branch connects more than two components. How can we tell that R2 and R3 are directly in parallel with each other? Well, if we do our node analysis and we say, R2 connects from node 1 to node 2, and R3 also connects from node 1 to node 2. So that tells us that the R2 and R3 section is in parallel. Because remember, the R2 branch is sharing the same start and end node as R3. So those two are in parallel. Now let's apply the same rules to a slightly different layout here. So we'll highlight our different sections here. We've got node 1, node 2, and starting with the purple branch, we're connecting the battery to R1. The purple branch is only connecting these two components, the battery and R1, so this must be in series. These two components, the battery and R1, are in series with each other. R1 connects then onto node 1, but then it splits to R2 and R3. So the green branch connects three components, therefore there's a parallel section in here. And likewise, the orange branch connects more than two components. It connects the battery, R2 and R3, so there's a parallel section here. How we can tell which components specifically are in parallel? Well, if we look at node 1, the R2 branch connects from 1 to 2, and the R3 branch connects from 1 to 2. So that tells us that R2 and R3 are in parallel with each other. So to summarize that, the battery is in series with R1, which is in series with the parallel combination of R2 and R3, which then connects back into the battery. Alright everyone, I really hope you enjoyed this short video on series and combination logic and being able to use the rules to identify which resistors are connected in series, which resistors are connected in parallel, and then applying that to identify which resistors are series and parallel in a combination circuit that involves elements of both. Alright, see you next time. Bye.